Welcome to the CS2. In this Python tutorial, you are going to learn that how to solve a coupled differential equation using Python coding. So here we have three sets of differential equation: d by dt of x, d by dt of y, and d by dt of z, and they are coupled in your xyz, and you have their initial condition as x0 equal to 0, y0 equal to 3, and z0 equal to 3. So we have to take care of these equations and these initial condition to obtain a graphical solution, to visualize it through Scipy. So let's code it. Okay, so first I will define these equations. So I will use functions to define these equations, right? So I will define my first equation as, say, I will here give definition, and I will say coupled differential equations, CD means, and I will pass my, say, x, y, z, and I want my t as a independent variable, right? Now we have defined. Now we want to like define our dx by dt, dy by dt, and dz by dt. So for that I will define here, say, x equal to xyz of 0. So for x, similarly I can define y equal to xyz of 1 as a vector, and xyz of 2. So basically this defines as a vector, right? Now you want to return your equations. So for that, define here. You can define dx dt equal to this equation as minus x minus 4 into y minus 3 into z, and similarly you can turn your dy dt equal to 4 into x minus 10 into y minus 4 into z, and then dz dt as minus 3 into x plus 4 into y and minus z. So we have defined our equations. Now we need to return. So type here return, and you can turn in the array. So dx dt, then dy dt, and dz dt. Now this much you have done. Now we'll solve it. Okay, so for solving, here you can import from Scipy dot integrate import ODE ENT. So this will solve differential equation, right? So this package will solve. Now I will define my initial conditions, right? So I'll give initial conditions or initial values. So I will give, say, xyz 0 equal to, I can give, say, we have 0, 3 and 1. So I give as an array 0, 3 and 1. Now solve it. Okay, now solve it. So for solving, type here solution as a variable and give ODINT function and see what it takes. So basically it takes your function, your initial value and your independent parameter t, right? So here you give your CD, you give your x, y, z 0, and then you give your t. So now t we need to define here. So t you can define as np dot linear space. You want to go from 1 to 100 and 100 data points, and then you can import here import numpy as np. So this take care of your array, right? Now we have defined the solution and check it what it returns. So if you check solution, so this is the solution. This look like it contains 3 array. So you can check the shape of this np dot shape. So basically it contains your 100 rows and 3 columns, right? So you have to extract each column for x. So you can suppose you want to extract your x solution. So x of t I can give as a, so x of x equal to x of t. Here it can give as solution, and you have to extract the first column. So this will give your x solution, and similarly y. Well, so now we'll plot the solution. Okay, so plot the solution, right? So for that, use for loop for I in range of 3. We have like 3 equations. Then type here plt dot plot t comma solution and give here your column number, right? So you can plot it. So here you can see that this is solution, how the solution looks like. But here you can observe that the solution has like meaning in this range. So I will just change my t number, t space number, and you can observe here that how your solutions looks like, right? This is how the solutions look like. You can also okay, so this is how your xyz looks like. You can also give some label to this. So label equal solution of bracket, and you can give format I, right? And then type here plt dot legend, and here you can see that you have three solutions for 0, for you can put here yeah, you can put solution, yeah, it's fine. Okay, so for your x, y and z, right? Or you can see here. Okay, so we have done the solution successfully. So you got your three solutions for this differential equation, right? So I hope you have learned this solving techniques of coupled differential equations and how to visualize a solution corresponding to that. So thank you.